this is going to be, let's see, I think lesson 3 for this Unreal curriculum. And today we're just going to be going over some more blueprint stuff. I wouldn't really call it too advanced, but just part 2. All right, so I think, Ben, you're going to go ahead and grab the screen if you want to get started.
We need to enable the screen sharing.
Yep.
You me to start with the lesson 3 slides.
Yeah. All participants. Okay, try now. One day I'm going to remember to actually set that setting up before we get started.
All right, can you guys see?
Yeah.
Okay, cool. So like Daniel said, this is going to be part 2 for blueprints. Sorry, this is the first time I've used Google Slides, so it's going to be a little scuffed. But okay. So the videos you watched, I guess 2 weeks ago or a week and a half ago, were about gameplay framework documentation, adding input and interaction, and then blueprint communication. Today we're going to be touching on a little bit of those kind of things. We're going to start with kind of the gameplay framework and kind of the more of the theory stuff behind some of the different types of classes, as well as their relationship to each other, and why you'd use one versus the other. And then later we'll be doing a tutorial about adding input to the tutorial we did a couple weeks ago. And then Daniel will be doing the blueprint communication tutorial. But to get started with the theory, I think one of the questions that was asked before was, what's the difference between blueprint classes or actor blueprints versus level blueprints? And Daniel kind of answered this a little bit previously, but to kind of explain further, the really nice thing about blueprint classes or actors is that they can be instanced. You can use them multiple times and change different variables between them, whereas a level blueprint is just static for that level and only that level. You can create multiple levels and then have multiple level blueprints for separate levels, but they will only ever affect that singular level. So if you had something very specific, or you're utilizing some sort of engine assets like target points or other volumes that aren't part of a class or a blueprint class, you can reference them from a level blueprint, and it's much harder to reference them from an actor class. I think to kind of go further with the idea of this versus that, another important one to understand the distinction between the two is pawn versus character. Because a lot of times it's kind of intuitive to think that the character is the player character, and this isn't always the case. A character in Unreal is simply a class of actor that has a skeletal mesh component as well as a movement component. It does not mean that it can be the player or even an NPC. All it has is just that skeletal mesh component as well as the capability of movement across a navigation terrain. Now, a pawn is something that can be possessed by either the player controller or an AI controller. And different controllers are essentially what allow an actor to gain input from something else, whether that is the player from using your keyboard or your mouse to allow your character to move, or an AI system giving the ability to move to some sort of NPC character.
Yeah, I would just jump in right here. I think like a really good example of this, even though I don't think the games are made in Unreal, is if ever played like a FIFA game or kind of like a sports game, you could think as like each individual character as the pawn that's like moving around. And then you as the player controller control different ones at different points in the game, so you're able to like switch off. And then the AI controller, when you're not controlling one, is possessing those pawns. I think that's
Right.
a pretty helpful example. At least for me, that was helpful for understanding the like controller versus pawn.
Right. Did you want to just continue with the game mode, game state, player state?
Yeah, yeah. Oh, okay. Yeah. So, I guess going off of that, the yeah. So then you have the game mode, game state, player state. Um, and so a game mode basically is kind of defining the rules of the game. You could think of it as the rules, and the game state shouldn't really contain logic, but really contain a lot of just variables that kind of define the state of where the game is at right then. And player state would be the same way, but just for like each individual player. Cool. So, can you go back a slide? Because I just want to say one more thing about all of this. Um, so I know Shake's done a lot of stuff in Unity. And for anyone coming over from that, you'll notice that like Unity doesn't have out of the box a lot of these like classes and hierarchy. And that's one of the things that we really like about Unreal is that they provide this for you. So all projects kind of follow the same structure. So it becomes a lot easier jumping from project to project to see like, okay, I know I should look for this in the controller or the pawn, or this should be done in the game mode. It really just helps, yeah, basically moving from project to project and just having all projects made in Unreal have the similar structure.
Okay. So next I'm going to be sharing my screen here with the Unreal project and showing you guys adding input to the previous tutorial that we did a couple weeks ago. So just to, I guess, my mouse is, let me stop sharing for a second. That's weird. There we go, okay. So the previous tutorial was essentially hooking up components and just kind of using timelines to animate opening a door and closing it on exiting the overlap. Today we're going to be doing a little bit about changing that to like a hotkey. So you're pressing the button on your keyboard to open and close the door when you're within range of it. Move this little screen sharing thing out of the way so I can see my tabs here. Okay. So first things first is close out some of these. This is what it should have looked like before. But what we're going to do is change the input here. So you can type in keyboard function, I believe. Keyboard event, and then you can type in like something else here. So let's just do E. And essentially what we're going to be wanting to do is just open and close the door based off of this input key. Now this is really important because this won't actually work because this actor here, this blueprint door, is not receiving input from the player controller or anything. So even if we tried to open this, it's not going to actually do anything. We would instead need to add this into the player character or whatever character that the player is currently possessing. But what we're going to do is create some custom events so that we can open and close this door from a different actor. Let's hook them up. So for this, since I'm using the third person example map, I'm just using the third person character, which you can find by just typing into the search bar. And there's two different ways that you can add input. You can do exactly like I just did before, where I typed in keyboard, whatever function, and then just chose a key. You can also select this key node here and then change that input key up here in the top right if you're having trouble finding one of them. Or you can go into your project settings and map it to an action mapping. Now, there's two different types of mappings here. There's action mapping and axis mapping. And this is the difference between the two of them is that axis mapping is constantly pulling that key that's pressed. So whenever you're playing a game and you're like pressing W, or you're playing on a console and you're like moving with one of your analog sticks, it's constantly checking to see what it's doing with that button and then adding that input every single time it's pulled, which is constantly. And action mapping is you press a button and it checks and it pulls it once. So if you were to put your move forward key, like W, on an action mapping, and you pressed and you held down W, it would only move you forward once. Whereas an axis mapping will continuously move you forward. So you could add an action mapping here and just call this like open door and then like set it to F. And it would essentially do the same thing. The cool thing here though is that this would then be accessible through all of your other blueprints instead of just that third person character one. So now if you typed in open door, you'd have a specific input action for your open door instead of just that F. But we're just going to stick with F because that's a little simpler for right now. But so what we want to do is somehow get the reference to that door and then call that custom event that we created to open it. There's a couple different ways that you could do this. You could use something like get all actors of class and then target that specific door. But what I want to do is instead get that exact reference, which we can do similar to the way we did it the other week with the collision, using the on component begin overlap. So what I'm going to do is check to see if the target that we're overlapping is the BP door. And then if it is, we're going to keep that variable. And we'll call this door. Now, if we drag off of door reference here, or if we drag off this reference, we can call that open door function. So we could just go right in here into press and hook this up. But the problem is, if we were to press F and we have not done this overlap yet, it's going to start triggering some errors for us. And this is kind of one thing that you're going to have to start thinking about is kind of handling your exceptions and handling the scenarios where data is not actually being passed yet, but your code is hooked up so that it does. So what we'll need to do is utilize this reference to check to make sure that there is something inside that reference. And we could do this by checking to see the not equal node. So essentially, if the door reference is not equal to nothing, then we want to be able to open the door. And since that's a Boolean, a true or false value, we can hook that up to a branch and then plug that into true. And then what we can also do is do this exact same thing for the released part of it. And then grab the other one, which is the closed door function. And so now, go over to this door and we hold F, it'll open and it'll close. Now that we have one final thing to do, and that's if right now we have nothing for if we get away from the door. So like if I press F and then I leave from the door, I can still just keep opening and closing it from, however far away. And so we can do something very similar to the previous tutorial where we're using the on component end overlap. And essentially, we're just going to refresh that variable here. So we're checking to see if we've stopped overlapping that door. And then if we have, we're just going to empty out that reference. pressing F and nothing's happening. So yeah, that's pretty much adding input and a little bit about talking between different blueprints. Do you guys have any questions so far? Nope. All right, then I think I'll hand it off to Daniel to do the more advanced blueprint communication.
Yeah, so I'm going to talk about blueprint communication. So let me go and share the screen. Do my whole screen there. Let me get this set up. Can you guys see my screen? Yeah, okay. So for this lesson, you should have read over this page that basically talks about the different ways that blueprints can communicate. I'm just going to go quickly over them and then do an example project that shows each method, I guess. So you have direct blueprint communication, which is what you've been using before, when you kind of just have a reference to a variable and you can drag off and call functions and get values from it. But the one that I'm going to focus on today is the event dispatcher. And this is how blueprints kind of listen to each other. So you bind events with different blueprints. And so when an event is called, whatever is bound to it is also called. So I'm going to show you guys an example project that uses that. So we're just going to launch the engine. So we're just going to do a standard new third person. We're going to go So we're just going to be kind of creating a 3D version of PacMan, and we're going to use this as kind of the starting place for some of your assignments too. So always fun waiting for the editor. Okay. Okay, so if we start here, let's see. All right, so we're just going to make a copy of this basic third person level. Oh, just took a second. All right, so let's start there. So first thing we're going to do is just clear out a bunch of stuff and then rebuild the lighting so we don't have that shade or have those shadows there. Yeah, another fun part, just waiting around for lighting to build. So while we wait for that, we can just do some folder setup. So we're just going to make a PacMan folder and kind of keep everything in there for now. So one of the most important pieces of PacMan are, I'll call them just the balls, like the little orbs that you go around and eat. So that's the first thing we're going to start with. So we're going to make a new actor. So a new actor, basic actor, we're going to call it a ball. And so all this is going to have is a static mesh. So we'll call this the ball. And then keys are kind of fast. So we're going to also add a collision so that we know when our player has actually collided with it. Nope. Try to get it about the size of the ball. Okay. So let's just see what happens if we drag one of the balls into the level. Okay, that collision's pretty small. Let's just keep it. Okay. Wait, where did it go?
Oh, you don't have a static mesh for it yet.
Oh, yeah. You have to actually add the static mesh. Good point. A shape sphere. Okay, there we go. Now we're cooking. Just kind of center it. 5, 3, 2. All right. All right, so first thing we notice is that when we collide, we don't go through it. So let's change that. So on the static mesh, you change that by doing here. So it's collision. We're going to set that to no collision for the static mesh. So we can walk right through it. Okay, let's see. The next thing we want to do is add some collisions to the sphere. So let's do a begin overlap. Let's get the other actor cast to third person character just to make sure that we're actually we're colliding with the character. And let's just do print string to see, make sure that works. All right, cool. So next thing we're gonna do is just kind of scale this down a little bit, make it look a little better. Okay. And so when we collide with a ball, we want it to disappear. And I'm gonna kind of go through a basic way of implementing that, which would just be doing destroy actor in here. Okay. All right, so we kind of got the basic implementation of the orbs that we wanted. But now if we wanted to add more functionality to this, it doesn't really make sense to add it to the ball because we want to keep that as small as possible. So we're going to actually make a new game mode. So we do that the same as any actor. We go to blueprint class. And then I like to do it this way because you can see all the classes. You could just do a game mode base, but I like to go here and just type game mode. Okay. PacMan. Okay. So if we open this, you'll see it looks like a pretty standard blueprint. You can have the event graph here. So one thing I do want to demonstrate is how you actually change the game mode. So I've made the game mode. When it begins play, it should just print this string playing PacMan. But if you see when we start the game, it actually doesn't do that. So we have to switch the game mode for the level. So each level has a default game mode. And you can just switch that here by going to Blueprints, Project Settings, switch it there. And so now you'll see that we are playing PacMan. So the first thing that we want to do is spawn actual board of this. I'm not going to write that out now. I have that already made. I'm just going to copy and paste it. All right. Uh-oh. All right. I'm just going to copy all the logic. One second. So it's just going to take a vector, describe where the bottom left of the board is, the size of the board. I'm just going to do a square board. And then how separate how much distance in between each one there is. So we go bottom left. Sorry about this, y'all. I should have had this prepared more. I thought I could just copy and paste it over.
So this would actually be a good time to jump in and say, if you're wanting to, for you guys for the future, if you guys are wanting to move functions or macros to other projects, you can create what are called blueprint function libraries and blueprint macro libraries. And just like when you migrate content from one project to another, if you have those functions housed inside or those macros housed inside those libraries, they become very easy to translate. But you have to, do that ahead of time.
Yeah.
Because again, it's like if you made the function first in like a class and then you made the library afterwards, you would still have to do exactly what Daniel's doing right here and like bring it all back over into the library to change it.
Yep. All right. Oh, okay. Always good to remember you actually have to call your functions. All right, cool. So we get a board. And then if we run over them, nice. It actually deletes them as we go. Okay, let's delete that. Okay, so one thing that you might want to add to a game like this is making it harder so that you have to go over each ball twice before it actually destroys. And I think this is kind of just like a random mechanic that we're adding, but it's going to demonstrate why that would be hard to do in the ball blueprint and why it might be better to do things like this in the um, basically in the game mode. So we don't really want to make much change to like the ball. We could add a counter here and then yeah, we could add a counter here and then keep track of that in each individual one. But it would be much better to keep track of that in the game modes because that's kind of like a gameplay mechanic. So the first thing that we got to do is move this destroy actor. Since we don't want the ball to be destroyed every time, we only want it to be destroyed if it's been run over twice. And we're going to move that to the game mode by adding an event. So like on,
I think we lost Nautica.
oh yeah, Nautica had to jump off for class.
Oh, okay.
So yeah, he'll just watch the recorded version. So basically, we want the ball to have an event called when it is basically when the character actually like runs over it, so that other things can do logic after that. So that the so this way the game mode can has something to bind to know to like keep track of how many times you run over each square. So we make the event here, so the on character overlap, and then so every time we spawn a ball, we're gonna bind to that event. So now this has to take in its own function. So let's just make a function call. It's probably this. So right now we're just gonna have it print hello. And the way you bind an event, you go create event. And so it's gonna find all the events with the same signature. So this has like no input variables, so all of these match it. So we'll go ball overlap, which is our function. Compile all of those. So now we're getting the hello, but that's coming from the game mode. Okay, so now we can do it where we keep track of how many times each ball has been run over, and then use that to figure out if we need to destroy that ball. So we're going to make a map variable to keep track of that. So for each ball, it's is going to be mapped to an integer, which is going to represent how many times that ball has been like overlapped and hit.
Would it be easy for the balls themselves to have a reference of how many times they've been run over? Does that make sense?
Yeah, so you could add it that way, but I think the benefit of having it in the game mode is that the ball basically doesn't know that that's part of the game mode. So you could have like a ball with a different, make a different game mode that you don't have this mechanic, and you wouldn't have to have any logic change to the ball. Does that make sense?
Oh, I see. So that makes the ball asset reusable in different levels.
Yeah, exactly. The
Okay.
ball asset becomes reusable because you want your assets and blueprints to do just the bare minimum functionality. So, oh, it's not set. It's add. So we're gonna add a reference to the map And so obviously each one starts at 0. And so now in the ball overlap function, we have to make a change. One sec, I need some water. So right now the problem is the event doesn't have a signature, or doesn't take any input, or give any input, I guess is a better way to phrase that. So we don't actually know which ball we've collided with. So to change that, this event is going to have an input, which is just going to be the ball. And it's going to be a reference to an A ball actor. And then we're just going to pass self. So now if you see I have an error. So when you bind an event, it has to have the same signature. So you see this function has no inputs, so it matched it before. So now we have to update that to get it to actually work. So okay. So now the function that's being called by this event has the same signature, and so it compiles again. So now we have a reference to the actual ball that was hit, and now we can add our gameplay logic. So we're going to do this. We're going to do a find. Usually you'd have to write some logic if you don't find it, but for now we're just going to kind of go with the happy path. So this is the integer of how many times it's been hit before. So we're going to do a add integer. So add 1 and then do a branch off of that. Oh, we're going to do a check first. So we're going to see if this is greater or equal to, for now, we're just going to hard code that to 2. Okay. So if that, yeah, I think that's right. So the second time it's hit, that will be true. So we want to take a reference to the ball. And now we can re-add the destroy actor. So false. Okay, but if it's not true, we need to reset the value in the map. So in maps in Unreal, there's no like update function. You just call add again. And so if you look at that like box that came up, so the second sentence, if something already uses the key, it'll be overwritten, which is the functionality that we want. So we want to take this new incremented value and add it to the map. And then the key for that map is going to be the ball that we've just hit. Okay. So let's go ahead and actually add a string just to make sure that this is working. So we're going to print the new value. So the second time it gets destroyed. Okay, this is the bug. All right. So if you see it's like printing 2 instead of 1, I actually ran into this bug when I was doing this project earlier. And it's actually something that you should like, I guess, watch out for that is pretty subtle. Okay, so you would think that this value, that we're using the same value here as we are here because they're coming from the same node, right? So it's kind of weird that like it's saying it's printing 2, but then this it's going that way because it's false. So if it was 2, it should have done destroy actor already. Does that seem like, see how like that's kind of like a weird bug right now? So this is a pretty subtle thing, but if we look at like what's actually happening, so when it gets to this branch node, it's going to do a backtrace. So it's going to do okay, it's going to say, okay, I need this condition. So I need to do this node. So I need to add 1 to something. Well, what am I adding 1 to is whatever the key is in this balls to hit. So it evaluates this whole chain to get this Boolean. And then we call branch because it's false because there was 0 and now it became 1. And then that evaluates the false. So we re-update the value in the map. And then when we call this print string, what it does, it evaluates this entire backtrace again. So it evaluates that, it evaluates this +1. Well, what are we adding 1 to? Is we're adding it to whatever is in the balls to hit map, which we just updated before. So that's kind of why there's that like weird bug where it's printing 2 instead of 1. So to get around that, what we should really do is this. So we should get the map again, call find, and then call it there. So when you have like weird bugs like that, you have to remember that each time a node is called, it completely reevaluates the like input into it. So let's change this. 111, and then it's not printing 2 because it's destroying them. So if we go back over them. So that is just kind of a basic example of how you would use an event dispatcher to communicate up to the game mode some information that it needs. All right, so that's basically the tutorial. So for your assignment for this like lesson, you're gonna build off of this. There's a little bit more code that I'm gonna give you to start with, but I'll add some comments so that you can see what's going on. And basically you're gonna make your own game mode with different game mechanics and try to make the ball actor basically as reusable as possible for your new game mode. Does anyone have any questions about any of this? Any parts that were unclear?
I guess I just need to look at the code more. So when I look at the assignment, I think I'll understand exactly what's going better. I get the general gist of it, but the function and stuff is a little bit ambiguous.
Yeah, definitely looking through the code is the best way to do it.
So is it the actual like function itself that is confusing you, or is it something inside that function?
I was a little
Or
bit
is it
confused on the spawn board and how that was set up.
Oh, yeah, the spawn board is just basically like a double for loop that spawns the balls at like different increments. Like I said, I wrote that. I should have planned on a better way to transition, but I wrote that before because I didn't think you guys needed to see like just a basic double for loop. But yeah, it's just a little bit of math basically, and then the spawn actor. I think the important part is the stuff that comes after it, with the like binding to the event and things like that. So one thing I do want to actually show before we stop that I didn't, that you're gonna have to know how to do for the assignment is how to make a new game state and how to hook that up to your game mode. Because we're gonna have you basically make new game states too. So like we said, the game mode holds kind of all the logic and the rules of the game, and the game state holds the variables that everyone would need. So let's make a new game state. Call it game state PacMan. Okay. So kind of the same thing. It's a basic blueprint. So let's do just a print string for hello. So again, like if we just start it, there's no hello message because it's not hooked up to the game mode yet. So the game mode is tied to a game state. So if we look at here in the game mode blueprint, and when you click it, you have the classes. So you just change the game state that you want the game mode to be spawned with. And so we would just go game state PacMan, recompile it, and then hello. So now anything that we do in this game state actually would work. And then you'll have to make modifications to the game state provided in the assignment, and it should already be hooked up, but whenever you make a new one, that's how you add it. All right, any questions on that?
You can also adjust the game mode and those different parts that make up the game mode in your project settings, the default editor one.
Yeah. All right, well, if that is all, or if there's no questions, I think that's all that we have today.